Hey, hello and welcome to today's GFG problem of the day. Hope you all are doing well. So let's see today's problem, number of paths in a matrix with k coins. Okay. So we will be given a matrix, right? We'll be given a matrix and each cell represents number of coins and will be given a total number of coins k equal to, for example, let's say 12. Okay. So what we want to do is, and some conditions are right. So what we want to do is we want to find a path from the top left to the bottom right. Okay. Whose sum is equal to this given k, whose sum is equal to k. Okay, k is the number of coins, and the condition is we can move either to down or to right only. Okay, either to down and to right only. So we have to return the number of such possible paths. Okay, so here in this case, there can be two paths. Let's see the paths. So here 1, 2, right? 1, 2, 6, 2, 1. This is one path. Okay, this is one path. That is what 1 plus 2 plus 6 plus 2 plus 1, which is nothing but 3 plus 9, right? Equal to 12. 12 is, which is what we want to find out, right? The sum should be equal to k. The sum of the path should be from top left to bottom right should be k. Another path is 1, 2, 3, 5, 1. This is the path. Okay. 1, 2, 3, 5, 1. Right? 6 plus 6, 12. Okay. So this you want to return the number of paths. There are two possible paths in this example. Okay. Now, how will we solve this problem? The question is how we'll solve the problem. So if you observe, uh, see, we have to move either to not either, we have to move right and down, right and down in order to find all the possible paths, right? All the possible paths. And again, from this cell, we have to move right and down. Each cell we have to move right and down, right? Right and down. Okay. So there'll be two branches from each cell. There seems to be two branches, right? So this seems to be a problem of recursion. Recursively, we'll go to from each cell, we'll go to the down and the right. Okay. Okay. So in this way, we are going to move ahead. And one more thing is, for example, right, at each I, j, so whenever, for example, there are k equal to 12 coins, right? K equal to 12 coins. We start from here. So we move down. So what we're going to do now, after moving down, right, how many number of coins are left? We will reduce the number of coins from the current cell. So 12 minus 1, 11. We'll pass 11 over here, right? So from this cell, when we go to the right, we are going to 11 minus 2, right? 11 minus 2, the number of coins from the current cell, right? It will be 9. We'll pass 9. Here also we'll pass 9, current cell, right? And then from, if we, there's only one option to move down, so in this case 9 minus 3, current cell 6 will pass, right? From here, how much it will be? 9 minus 6, right? How much it is? 3. Here also 3. So in this way we are going to move, right? And when we reach here, the number of coins remaining, the remaining number of coins should be equal to this bottom right cell. Okay, bottom right cell. Now I, j and k. So what? So if you observe, right, at certain point, at certain I and j and a k, remaining k, right? What is the remaining k? Whatever is the remaining k, right? So if given a bigger matrix, there'll be a point wherein we already might have computed at the current I, j and this k, right? And the remaining k, for example, this one, right? For example, this one, 1 comma 1 comma 3. So it may be the case that from a certain, right, there were multiple paths coming to this, right? And the remaining number of coins, right? So here, okay, so we might have already computed this particular location, right? This particular, okay, sub problem, we'll say this particular sub problem. So this is a repeated sub problem. So what we'll do is we'll also store, we'll also memorize, we'll use memorization to store the result, right? So because there can be repeated sub problems, we are going to use memorization. Okay, so let's quickly write the code now. Let's quickly write the code. For example, I'll write Java code which is almost similar, right, to C++ as well. Okay, so let's have a DP array, okay, for memorization. So what will that DP array contain? Okay, let's have n plus 1, right? Plus 1, because we want to calculate for k plus 1, right? K plus 1. Now, we want to calculate why k plus 1? Because we want to calculate for the k, right? The k coins, which will be at location k plus 1 only, because we start from 0, right? 0th location. That is why. Okay, so now let's let's initialize this with -1, right? This dp with -1, dp, and then for long row 2, right? Okay. So we'll bear with me. Okay, arrays.fill. So I'll show the C++ code as well. Okay, so here what we're doing is we are initializing the dp matrix with -1. Okay, filling with -1. Okay, this is done. This is done. We have filled. Now then what we are going to do is we are going to write a function. Okay, for example, which will return, find the number of paths it is, right? We'll pass I, ij, right, which will be starting from 0, 0, right? And we should also know the end of the matrix, right? N, the size of the matrix. Then we'll have K, the number of coins, the array, the matrix basically. Array is nothing but the matrix, and this DP array, right? So let me write long F, right? What is int I, int J, int N, int A, R. This is long, right? DP. Okay. So we are passing here. Now what we're going to check, if I equal to the base, the bottom right condition, right? If I equal to n minus 1, j equal to n minus 1, and the remaining k equal to r of I comma j. This is bottom right condition, right? If it is, the remaining k is equal to the bottom right cell value, right? Okay, that means return one. Okay, let's write the base conditions later on, right? Let's write the base condition later on. First, let's write the so now from the current cell we have to move down, right? We have to move down. So what I'll do, I'll come to this base condition again. Okay, first let's go down from the current cell I plus 1 comma j, right? And now when we go to the to down, basically what we'll do, we will also deduct the coin from the current cell, right? The coin from the current cell, k equal to k minus, right? I already showed you, right? K, and then we'll pass this dp, right? Similarly, what we're going to do, we are going down, right? Now we'll go right. We'll go to right, I j plus 1, okay? And this will be same, remaining, right? We'll deduct the number of coins from the current cell, okay? And what we're going to do is, what we're going to do is return d plus r, right? D plus r. This will be the code. Now to memorize, right? We are going to use memorization. So what we're going to do is, we are also going to store, right? D, I, J, and the k, okay, equal to d plus r, right? We are all we are also storing the dp array, right? And then we are returning. So here if you see, we are going down and we are going right over here, right? So here, now if you see, also you must have observed that we are doing k equal to k minus, right? Deducting. So this k will be now the updated one, right? The updated one. So we are checking if it is the last cell, the bottom right cell. Okay, the bottom right cell. Then we are checking if it is the remaining number of coins is equal to the coins in the bottom right corner. If it is, then return one. Okay, we have found one path. That means we have found one path. Okay. Else, what can be the other condition? If we have reached n, right? Or we have not hit this condition, right? Hit this condition, but we have reached past, right? So if such is the case, or we have exhausted the number of coins, so the path is not possible, right? The path is not possible. Return zero. Return zero. And okay, if this is also good, okay, this we have not exhausted. Then what we'll check, if we have already stored, if you already computed this, if you have already come to the path wherein we have done the calculation, right? How it will be? If it is not minus 1, then return dp of I, j, and k, right? Just simply return this. Okay, so this will take care, right? This will take care of all the number of paths we are returning. This is a main function we are returning from here, right? So let's submit this. Let's compile this. Oh, there is some yeah, what it is saying, f long d equal to I plus 1 j n k minus 1. No, what is the problem? I cannot. Required and found. Required and k. Add. Yeah, so I missed add, right? I have to pass add as well. Okay, so let's compile this. So yes, let's submit it. So yes, the solution is accepted. Okay, let's see the C++ code as well. I've already implemented this code. It's almost same. If you see here, the number, it will be starting from here, right? What we'll have, we'll have a DP of the three-dimensional DP, n plus 1, n plus 1, and k plus 1, right? Which will initialize with minus 1. Okay, and then we are filling here with minus 1, right? We are filling here with minus 1. Okay, fill the row with minus 1, and then we are passing ij as 0, n, k, and add the matrix, right? And the DP array, right? So similar, whatever we have written, right? The base condition, if we have for the bottom right corner, right? The remaining number of coins, if it is matches, then return 1. We have found the path. Else return 0. Here, if you have already computed, return dp of ijk. And here, go down, go right, and add d plus r, whatever it is, whatever path you have found. Okay, d plus r. Okay, so this is the code of C++. I hope you've got the solution. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.